great to see you all. I'm glad you survived the party last night, so it's nice that you're here to join us. We're a company based in Germany, and we've got a great product, which is mobile, called BI in a Box. We've been around for 10 years, and we've been doing BI, strictly BI, ETL, building up warehouses, third normal form. We're doing data vault these days, and we've got standard reporting, visualization, data science. So we've got basically these 4 pillars of things that we're doing, and we thought it's cool, but it's really techy, and it's really, really sort of difficult to be really agile and really fast. So we decided to put it all together and do a one-stop shop, because we didn't want our clients to have to worry about infrastructure. We didn't have them to worry about getting the components to work together. We didn't want our clients worrying about hardware. So we said, you know, what we'll do is we'll have a really cool platform to do data integration, data storage, data visualization, and data science.
Sorry.
And we love Murphy. So what happened was, last year, here, my boss, Jan Strackbein, and Christian Langmeier from Exasol were sitting together at the hotel bar. And they had a conversation, and they had the one or the other idea, and they thought, wouldn't it be so cool if you could just roll into your client, roll up to your client, put in a plug, and grab the data, and have the perfect possibility to have a great POC, rapid prototyping, and managed self-service BI all together. So out of that idea, we all have lots of ideas in life, but not all of them actually become realized and a reality. So after that idea, we got our BI in a Box, which is based all around Exasol, which is why we're here, where we're sitting there, and we've got the ability to have I have to read this, 6 mini IETX mainboards, 11.5 terabytes of SSD memory, 40-port networks, 24 cores, and 384 gigs of memory. So basically, all your warehouses, maybe not all of them, but most of them we could just go and put in there and plug it in and go. So it's amazing what happens at hotel bars. I wish I could remember what happened last night at mine, but that's another story. So the idea is that we have the Exasol. We have then an automated data loading tool, which we wrote ourselves. We call the Areto Data Chef. We're into cooking. We're into food. We're into adding value to data. So the idea is to have the data chef taking data files, CSVs or SQLs, creating automatically a Data Vault 2.0 schema with the raw vault and the business vault, creating then a business view for your end users to be used for data science or for reporting, standard or visualizations, and to have it governable, and just be able to take it with you and have one-stop shopping. So this is our BI in the Box. So we use this for various projects, many of them data science, natural language processing, or data science on graphs, classification models, the ability to do a real-time recommendation engine, to do forecasting and predictions. And it's all about getting the ability to see and have our clients helped act instead of react, based on quality data, based on a simple interface to get the data in. We've heard yesterday 80% of the data scientists' time are used, wasted, with data collection. So having it in BI in the Box, in the Data Vault schema, means you can actually get to work and get going rather than trying to get the data in and cleaning it. I'll pass over to Till, who will take us all through this.
OK, so it's working? No, not really. OK, so I go to the laptop. So I want to tell you a little bit more about what is inside this box. So what we did is, of course, we took an Exasol database, so that's why we're all here. wonderful database, really easy to use, very fast, and yeah, that's the database we love to play more with. So that's our basis. On top of this, Daniel told you, is our Areto Data Chef. I will show you in a second what's about this nice little tool. So that's a data warehouse automation tool, especially built for this purpose. So then we have a lot of data scientists who really want to work with this machine, with this box. And what they do is they build their models, they deploy their models, and then they put it into the normal data ETL processes, really to use data science know-how inside our ETL. On top of it, we have a Tableau server to visualize the data. And why we use Tableau server? Because we can apply a lot of governance here. So we can publish reports, we can restrict who can see which report. So that's really a good way of dealing with data governance at this time. So that's all inside this box. So yeah, and we call it just BI in a box. To be honest, I thought the first one we will build, it's much smaller, so that's a suitcase here, but that's not really a suitcase now. Our technicians, they took 5 Exasol nodes in here. I thought maybe 2 would be enough for the start, but okay, that's fine. So now it's even faster and even has more power. So then, yeah, what are we doing normally if we integrate data and if we prepare data for analytics? So the steps are still always the same. So I have to acquire data. I have to see where do I get the data from, which kind of data is it, and then I have to integrate it into the database. Integration is always the hard part, to see if different data sources really match. What's the customer ID from the CRM and the customer ID from a retailing system? Is it still the same? Can I match it? And that's always the hard part of integrating data. And then we have to transform data. We have to apply business rules. We have to deal with data formats, with data quality, and that's all what we do in the transformation part. And last but not least, we have to analyze the data, and that's why we have to prepare it in a way that analytics is able to use this data in a good and fast way. So then, when it comes to technical layers, I have a lot of interfaces. These interfaces have to be described, and they have to be stable, of course. Otherwise, we have a lot of problems integrating the data. Nowadays, we use a data vault architecture for nearly every new data warehouse project. So we are using Data Vault 2.0. That means for the normal integration of data, we are using a raw vault layer. And then for applying business rules, applying transformations, we are using Business Vault. So that's nothing new, but it's the architecture we prefer and we use in nearly every data warehouse project at the moment. And then for analytics, we use output tables. That could mean it's facts or dimensions, and dimensions, or even just a broad table where Tableau accesses and visualizes it. So what is our data chef doing at this, or what do we have to do with the data chef here? So one of the major tasks here is to describe the source. So for example, we have a CSV file. We have to describe the attributes. We have to say what data type it is. We have to mark single attributes as key columns, so the columns that contain the business key. And that's nearly all. So when we did this, we put it into our data chef, and it automates fully the raw vault, including all ETL processes. So that's if the data is OK, which is not every time, but if the data is OK, this process takes 5 to 10 minutes. You have described the CSV file, and you can load the data immediately into the data warehouse. Yeah, I will show you this in a second. Then the second part, the Business Vault layer, we are doing it the same way, but we are using yeah, the Swiss Army knife of ETL is simply SQL. So we're using SQL. We are building a query on our raw vault and a business vault, and the result of this is again written into our business vault. So we are using SQL as data source here, and using the same loading mechanisms to load the data into our data warehouse core. And the last step, it's nearly the same. We are building a file, or we're building a definition of output tables. This could be a fact table, a dimension, or just a broad table. And we are defining an SQL, and this SQL then is loaded into, or the result of this SQL is loaded into this target table. The process is quite simple, but as we heard yesterday, Data Vault is producing a lot of objects. And it's quite easy to store data, but it can be a pain really to read the data from a Data Vault system. So that's why we generate an access layer in form of views to access the Data Vault, but not the single Data Vault object. So not all the hubs, the links, the satellites, but entities. Like entity customer could contain the hub customer and all its links, for example. Yeah? So it's much easier to work with this Data Vault system and with reuse. And that's one of the major points why we are using Exasol, because using views is just perfect there. You don't have to persist all the data, all the single steps. Just use views, and it's quite fast, and you can use it perfectly. So that's what the Data Chef is doing. I will show you in a second on our live system. So the other thing is, was told today in a lot of times, so that's quite easy for me now, is the data science integration. So what is a data scientist doing? He's taking data, he's building models, and he's training models. So we have our data warehouse, where already a lot of data is integrated, and then he takes external data, CSV files, other databases. He puts this into his model using the tools he likes. R, Python, Jupyter notebooks, whatever he likes. And then he builds his model. So that's always the first step of applying data science. Then in a second step, we are deploying this to our Exasol database. And we heard it already today using user-defined functions and the new bucket file system. It's really perfect to implement any programming language you like, deploy it into the database, and then use the user-defined functions as function and integrate it into the ETL process. So that's the last step then here. We have the user-defined function inside the database. We can use this for reporting. We can use it for our Data Chef, integrating this logic, these algorithms into our ETL processes. And just use it as a perfectly function with the data and the power of our Exasol. One step here, maybe the data we still need, we integrate it with the Data Chef. So we have one of our data scientists here, the poor guy who takes 80% of his time analyzing data, deploying data, really doing things he doesn't want to do. And we gave him this tool. He had a limited knowledge of Data Vault, but he worked quite fast with this tool, did his own data integration, and so he could work with this architecture and with this tool and integrate the data into the data warehouse. So now we are getting a little bit more practically. So the idea of the data set I will show you in a second was, I was at the Worldwide Data Vault conference in the US last month, and I flew over to New York and had a quite thrilling bus travel or bus transfer from New York Airport to Manhattan. And I thought, okay, traffic in Berlin, that's just like kindergarten. New York is really, really tough. So I found this page here, or this website. It's a very good source for data if you need just data to play around with something. And so I got collision data from New York here. So all the traffic or all the accidents from the past 3 or 4 years are logged there. I took this data and tried to import it using our BI in the box and our data chef. So that's what I will show you now, hopefully. Yesterday, most of the live presentations failed, so I hope mine will not. So, that's fine, OK. So we just start with the data chef. So underneath, there's the Exasol. I can show you. I like using dbeaver, so that's really a fine tool. But yeah, it's just a good database here. So I will log in. Oh, great. Let's see. So there's our data chef. So what it does is we have a web GUI here to control our ETL processes, to deploy our ETL processes. What it does is I have already deployed something here. So what we see here is a part of our Data Vault model. So that's raw and business vault. And what you see here is the blue ones are the hubs and the gray ones are the links. Yeah, so that's it. And we are hiding the satellites because when the model is getting really big, you can't find anything here. So we hide the satellites, but when I go to a hub, you can see there are 1, 2, 3 satellites at this hub and a lot of attributes which are already loaded into this model. So that's our overview of the model we already have deployed. And how are we doing this? So we are having a mapping here. And this mapping, the model I just showed you is generated by this model, motor vehicle collisions. So to see what is created here, there's a lot of DDL created here, so that's a really big mapping. I did a lot of logic in here, so that's not a normal mapping, but I wanted to test what our tool really can do. So that's in the first case, it's simply DDL. It's just creation of tables, of hubs, of different database objects. So how do I do this? So that's one part. So we are using a text editor, and that's what we have to define here. So that's the description of the CSV file, which is the basis for this import. And we are still using a text editor, so that's not very shiny, but it's a very fast way for us really to define or describe the source we are loading into our data warehouse. And what this is doing, we have a first part, which is the config part. So there we define how this data is loaded. So in this case, it's a CSV file. It's a special CSV model. So we're using semicolon as diversion. So that's a UTF-8 file. So there are some definitions behind this file. So I have to create, or can create different models here. So that's the first part. The second part is I define the mapping. So we have here the different attributes. And what I have to do here is to define, for example, a data domain or a data type domain. So that's a varchar of a specific length. And I can define, for example, which column is a key column. Yeah. So, but that's quite few information you have to add to the CSV file or to this data source you describe, and then you take the CSV file, load it with the data chef, and it creates all the data models and all the ETL processes. In a second step, you have this CSV file, and you load the CSV file again via the data chef, and that's what you see here. So I loaded already this file. So that's now the file loaded on my laptop. It took 6 minutes. That's quite a long time. That's the problem when you work with Exasol. If you have loading processes that take longer than 1 or 2 minutes, you think, there's something wrong. So in this case, I think, I had two virtual machines running on my laptop. The Tableau server machine was running mad with two CPUs at 100%, and it still loaded this in 6 minutes. So that was quite fast. So what is it doing? It takes also a lot of processes which are executed. So we are loading. So first of all, we are truncating the staging tables. Then we are loading it using import. Then we are creating all the hash keys we are using later in our data vault model. And then we are loading all the hubs, all the links, all the satellites. So for this mapping, there are 32 SQL processes which are executed in a row. Yeah. So that's quite OK. And it moved 21 million lines in this 6 minutes, which is not very good. We loaded it with our BI in a box in 1.5 minutes. So that's quite OK. And that's all. So the data is loaded into the data warehouse. If I get another file tomorrow or the day after, I just load it again with the data chef. So the data chef has a directory where he's listening if new files arrive. And if these files arrive, they are loaded automatically. The other source we have is any JDBC database or any database which could be connected via JDBC or ODBC. These processes are normally triggered via a scheduler or via dependencies on other mappings. So I can define if mapping A was started immediately after it is finished, start mapping B. So you can build here your own processes. OK, so I hope I have a little bit of time left. What I would like to show you now is just how simple it is to deploy. So I have another mapping here. So I have another mapping here which adds additional information to my hub borrow. So there are some population information, population density, area of the borrow. So some simple information which I want to load into my data warehouse. Yeah? So that's my mapping. I know, OK, it's a CSV file. I have these attributes here, and that's nearly all. And I have a CSV file which contains the data. So the first step I do, or the first step I normally do, is I take this code, I go to develop, and then I just run it. And if it's green, that's fine. I can see, OK, that's what you would do. Here's my hub borrow, and it adds a satellite borrow. And that's what you would add to this hub. Yeah, so that's the first test, the mapping I defined. It's OK, it's fine, it should work. So then I go to deploy, find the folder where I stored the mapping. And in this case, the data is already there in the same folder. So that's the sync file, that's my mapping, which defines the loadings. And the CSV file is the data. So I just have to see. So here, you can see down under here, so you can see the log file. So that's the only feedback we get at the moment. So when I push deploy here, down here in the log file, there should be what is it? OK, now it starts. OK, so now it generated 2 objects, and it loaded the 20 lines here. So that doesn't take a second. That's fine for 20 lines. So what it did now, it deployed all the objects into our data vault system. And it loaded the first data. So when I go to served again here and click on the hub borrow, you can see here are all the new attributes, and the data is already there. Yeah? So for the next steps, so now we have the data vault model, and the next steps would be to build really an analytical structure, so to build facts and dimensions, to build broad tables. And there we have the same way here. So I have got mappings, and these mappings take the data from the data vault system and load it into the target tables. And again, here we are using SQL, so I can show you example here. So now this is another loading type. It's a reload, so it truncates the table and loads all the data again. It's depending on another mapping. That means this mapping, if this is executed and it's finished, the mapping here will start automatically. Then I define all the attributes. It's the same manner as my mappings I showed before. And the target or the source for this mapping is an SQL, which uses the views we automatically created on our data vault. Yeah, so that's it. So you can use this SQL, test it on dbeaver, and if it's fine, just paste it here, execute the mapping, and then you have the data into your analytical area. And that's what Tableau can use, what a data scientist use. By the way, the data scientists often use the views on our data vault really to access the raw data or the most detailed data. But if you use the views, it's quite easy to do so. So when I did this, I can go to Tableau. So now I'm on Tableau desktop because I can show you really the data source, and that's now the data source I just loaded with the data chef. Here it's just a simple table with a lot of information, and I can then immediately use this table for analytics and see how collisions in New York really happen, where are injuries, where are more severe accidents. So that's quite easy then. So the way from taking the raw data, taking it into our data warehouse and analyzing it, it's very fast. So we don't have to bother about ETL processes. The ETL processes are of high quality, and if you don't like the quality we are thinking is good, all this is template-based, so you can change the templates, and if you need some specific ETL here, it's no problem to change the template and to implement it into this standard ETL process. So that's about this presentation, and that's all. I hope we are in time, or we chat a little time. Okay, so that is this.
We have a booth downstairs where we offer frozen sangria and frozen cherry juice. So if you don't want to talk to us about BI in the box, you can just come down and talk to us about sangria and a cherry slush, or you can find out more about what we can do and how we can help you out to integrate your data, to visualize your data, and to run data science on your data in a governmental environment. Thank you very much.